Welcome to our webinar about automation, continuous governance, and risk management. My name is Julio Bonis, and I will present you this webinar today. This is the webinar agenda. We will start talking about the problem that we face. That is what we call the AI committee bottleneck. Then we will go through a real-world demo of a tool that has been developed by Pacific AI to help to solve this problem. And then we will go deep into the architecture of adaptive governance, the Pacific AI brain, and finally we will provide with some tips about how to manage the life cycle of risk management in AI applications. So, talking about the AI committee bottleneck, what's the problem? The problem is that traditional risk management is something that typically is done annually or in annual cycles. Basically, it's performed by manual audits with a lot of human effort. But recently, we have seen how AI-based technologies are updated very frequently. We have changes in this technology that are every week. We have new models, new approaches, and that makes very difficult to maintain the speed in the evaluation of these systems. So unfortunately, we are having always some kind of compliance gap. The traditional risk report, that is a kind of point-in-time snapshot of the system and the risk of the system, and that has been used for evaluation and validation of these kind of models when used as medical devices, for instance, is not valid anymore. And we need to move into a more dynamic and kind of live stream governance. In this webinar, we will see how to achieve to this better state of things. Also, if you are a risk manager or are you involved in evaluation of AI systems, you probably are familiar with this situation. First of all, you are overwhelmed by a lot of regulations that change frequently, that are not clear, a lot of technical documentation about the system. What is more, you don't have a clear pathway of what are the tasks or the steps you need to follow in order to evaluate these systems in terms of safety and risk analysis. And at the end, what we need to do is to move from this classical waterfall approach, where you do a deep analysis of the system, and once you do the analysis, then you mitigate the risk. You do this once, to a more dynamic, more agile way of approaching the risk assessment, where you do a continuous system analysis, risk analysis, then you plan some mitigations, and then you immediately, on a very short term, you develop and deploy these mitigations, and then you return to reanalyze the system and so on. So you move from a point in time to a real-time evolution, and that of course should be accompanied by a well auditable documentation of everything. So it's not just applying agile methodologies as are applied in software development, but you need to, any document that you generate related with the risk assessment as the design assurance document, you need to link every piece of information or mitigation that you describe in this document with the specific evidence, a specific piece of source code. And this is something that in this kind of continuous or agile methodologies is very hard to maintain. That generates what we call the bottleneck in the AI committee. As more and more projects are presented and are asking to be evaluated, to be approved or rejected, in the case they need to be rejected, as this methodology is applied traditionally by manually, there's more and more overload of work to these committees, and this is making these committees are becoming the bottleneck. on the deployment of AI in healthcare or in other industries. So Pacific AI has developed a tool that wants to help to solve this bottleneck. I will go through a real-world demo now, so you can see how the system works. And later in this webinar, I will go in more detail on how the system works and what can you apply to your own projects or in the area of risk assessment. So this is a screenshot of the tool. You can see here that we basically have the three kind of user roles in the system. We typically will have the developer, that is people that is building the system. Then you typically will have another person within the company that is the risk manager, that is on charge of identifying the risks, documenting the changes and everything, doing a risk analysis, and sending this risk analysis to the compliance officer, that is the person or the committee that is on charge of reviewing this and making a decision about if the system can be deployed or should not be deployed based on the risks identified by the risk manager. Typically, you will start creating a system, what we call the target system. That is the system that you want to evaluate or to manage the risk of the system. You can, of course, put a description. That will make that you will have several systems that can be managed from this platform. This is the kind of documentation, technical documentation that you need to analyze when doing this risk analysis. You have descriptions of the system. You have operational manuals, user manuals, and these kind of things. You have even screenshots of the system or architectural diagrams, as you see. Or you can even have access to the code base of the system with programming code that represents how the system works. In this platform, what you can do is you can upload all these documents, no matter if they are unstructured. You will see. Basically, you will upload all the documentation that you have about the system, all the code base. As you see here, in this demo, we are just uploading a technical documentation, the code base, and an architecture description in form of diagrams. So you upload this into the system very easily. And once you have that, you can generate automatically, with the help of the tool, you can generate the risk assessment just clicking one button. You will see how it works. So once you upload the documents, you start the assessment. After about less than 10 seconds or 15 seconds, typically, depending on the amount of documentation, what you will get is first step, that is the architectural analysis of the system. The different agents that we will see later are able to go through the code base, to go through the technical documentation, and will extract information required for the risk assessment in a structured and very well-defined way, with different sections. You see the things like the system purpose, the data knowledge provenance, safety mechanisms, architectural overview, mechanisms for human overseeing of the system, and other intended operational environments and assumptions. All this information is extracted automatically by the agents specifically designed to do that. So these are details of some of the architectural information that is extracted by the system. For example, the tool is able to identify what is the system purpose and the operational context. In this case, it identifies that the system operates in US-based primary care practice, and that it uses WhatsApp, a business API, for communications with patients. All the things that the model is able to extract are safety mechanisms, guardrails, input guardrails, output guardrails, internal logic checks, or even the technological stack, which kind of tools or databases the system is using. And this is important for the tool to then identify specific risks that are associated with these specific technologies. In case the tool finds out that There is some missing information that is required to do a good risk assessment. The system is able to identify those gaps, informational gaps, and will return the user with some specific questions that need to be clarified because they are not included in the technical documentation or are not clarified by the evaluation of or examination of the code base. Once you have the architecture info of the system, the next step that you typically will need to do with in the context of our risk assessment is the first step is doing what we call the impact assessment. That is a document that is required in some countries before you deploy any system in real production. You need to perform an impact assessment. An impact assessment typically requires to put together different stakeholders that will analyze the positive and the negative impacts in different dimensions that are described in regulations. And this specific AI tool has a specific step and a specific set of agents that are configured to allow you to simulate this impact assessment, incorporating a set of stakeholders that are based on synthetic personas in LLMs that are simulating being the different actors that are that could be impacted by the use of this system. In this case, we have predefined synthetic personas as a doctor, nurse, administrator, patient, and you can select which people will you sit on the table to discuss about the impact of this system. You can incorporate new roles in case you need to cover different stakeholders for your specific system. And then by clicking a button in a question of less than a minute, you will obtain, based on the architecture that has been extracted in the previous step, you will get a full impact assessment for all the dimensions that are recommended by the regulations. In case of healthcare, you see impact on privacy, impact on fairness and equity on care, impact on healthcare workflow, impact on health outcomes and patient safety, and impact on patient autonomy. So for all these 5 dimensions, all the agents, all the personas will identify positive and negative impacts. These are some details of the kind of impact that were identified for these chatbot applications that we are using as an example. For example, the synthetic personas identified, okay, there could be a negative impact in terms of unauthorized access to the electronic healthcare record. Or there could be a negative impact in terms of fairness because there could be people that are unfamiliar with WhatsApp or digital communication tools, so they can have some issues to access to the capabilities of this chatbot system. But of course, it will identify also positive potential impacts like reducing human clinician bias in triage decision, because in the technical documentation and in the code, the tool has found that there is some specific Smith-Thompson engine that is described in the technical documentation that applies predefined clinical protocols, and that is expected to improve the quality of the triage decisions by the clinicians. So this could be also a positive impact of the system. Once you have the impact assessment and you have generated the list of positive and negative impacts, the next step in a risk assessment usually is to identify specific risks. And for each of these identified risks, you need to categorize the risk by level of risk, high, low, unacceptable, etc. And you need to identify mitigation strategies or mitigation actions to minimize or to remove the risk. That could be technical mitigations or could be organizational mitigations. That is also automatically done by the tool by just clicking a button. And when you click this generate risks, it will take a little bit longer because it will identify dozens of risks. but typically in less than 5 minutes, you will get all your system covered with the identified risks. And the tool will show you with all the list of, in this case, 42 risks identified. It will show you one by one. So the risk manager typically will check the title of the risk and the short description, and the risk manager that is always overseeing the system. The system is not fully autonomous, but is always a human, in charge of reviewing all these things. The risk manager will check this risk and will decide, okay, this risk makes sense or doesn't make sense, and will approve or reject the risk. In addition, the risk manager, if is aware of a specific risk, he will come specify the risk with just a brief title and a brief description, with the advantage that just by typing this short description, the tool is able to provide with a full description, more detailed description, will classify the risk by its level, by its impact or severity, and by its likelihood, and will provide automatically with a list of technical and procedural mitigation controls. As you see here, in this example, we have introduced the risk of patient not aware of talking with an AI, and the tool automatically has identified that you need to design and implement a user interface that explicitly indicates when patients are interacting with an AI. You need to integrate prompts to remind user periodically that they are talking with an AI. And in the side of procedural controls, not technical ones, you need to establish guidelines that ensure interactions maintain clarity, and you can conduct user education programs to help users to understand that they are interacting with an AI. So the system will save you a lot of time in terms of identifying mitigation actions and writing the details of the mitigations actions. That is typically something that takes a lot of time in this kind of risk assessment processes. Of course, as I have said, the user, the risk manager, is always able to modify any suggestion from the system. In this case, for example, if we identify a risk as a minor severity and a high likelihood of happening, that makes the risk unacceptable, but maybe the risk manager considered that, okay, in this particular system and this particular deployment environment, the likelihood of this risk is not high, is in fact is medium. So you can change any of the suggestions, and that will update the risk level automatically. You can then save the changes, and when you are happy, you end up with this final summary of the risk assessment that, if done manually, it could take hours and hours of work. And when done with the help of this tool, you can reduce, in our experience, you can reduce 90% the time required to obtain this report about risk of a system. You will get a matrix of the risks that identify each of the risks, what are the levels of these risks, and will generate a set of final reports in the format of documents, PDF documents, that you can then send to the compliance officer or to the committee, as you see here, to submit for review. And once you submit that for review, from the perspective of the user, that is the compliance officer, this compliance officer will receive this review. You can see down the 3 documents with the architectural info, the impact assessment, and the risk registry that can be visualized by the compliance officer or by the committee, along with the set of risks, the mitigations plan, and all that information in detail. And then the compliance manager can approve or can reject the deployment of the system, as you can see here in the next slide. And when the compliance officer makes a decision, he always can add some comments that will go back to the risk manager. So these suggestions can be sent to the developing team in this case, for example, to try to mitigate the unacceptable risk in the next 3 months because the system has been rejected. So that was a demo of how this kind of tools could work. In this case, a Pacific AI tool that can save a lot of time on this process. But now let's go deeper into how this system works and how the kind of things that is doing behind the scenes. So typically, a lot of compliance officers or risk managers are nowadays trying the most obvious or naive approach, that is, I will just upload these documents into an LLM, ChatGPT, Gemini, whatever provider, and I will ask the system, okay, generate for me a design assurance document. That is the first approach everyone tries. Unfortunately, this doesn't work too well because it's not reproducible, it's not auditable, and it's prone to hallucinations. So you spend a lot of time fixing the output of these generalist monolithic LLMs. So in fact, what you need is a more complex system and a more well-designed system that should include all these components that you see on the right. So this is, for example, the architecture of the Pacific AI tool. It has additional components, but this is an overview of the general architecture of the system, where you can see that it's much more complex than just sending documents to an LLM. You need an integration interface plane. You need a set of and specifically designed agents to execute different steps and different components of the risk assessment. You need a configuration plane able to configure the system with different regulations, different business logics. Then you need an orchestration plane that needs to orchestrate or organize or plan how the different agents of the agentic execution plane will work. And then you need persistent planes to keep the information about the systems. The core component of this tool is the governance knowledge object store. That is basically a representation of the system across time, so you can go back in time or go forward in time and see the state of the system at each time with the different versions. And this governance knowledge object should be accessible in RAM memory quickly to the different agents, so the agents can make different tasks around the system, and will include technical documentation, code and external policies and regulatory frameworks, and will allow the agents to generate the risks, identify risks, to provide with proposed mitigations, and to finally to generate the design assurance documents and other types of documents that are required by the risk assessment process. This is the core of all the system. Then we have the agentic execution plane that will execute what we have seen in the demo. First, it will ingest all the unstructured information. He will incorporate the different regulatory policies by an agent that we will see later. He will do the architecture analysis of the system, the impact assessment, the risk discovery, the suggestion of mitigation, and finally will organize the information so it can be approved or rejected. This is done by the agentic execution plane that is composed by specific agents designed and trained to solve specific tasks. For example, the ingestion layer will take the unstructured PDFs, documents, raw code that typically you will send directly to the LLM in your first naive approach, but that is not the best option to provide this information to the agents. In this case, the ingestion layer will extract this information and will generate subsystem trees to represent the code base, the relationship between the different components of the code. And for the case of documents, he will generate a hierarchical content trees that can be retrieved more easily by the agents. So the key here is to decompose the logic and not just scrap or provide with text. Another important agent is the impact assessment layer composed by different components, where, as I mentioned before, you will have like two phases in the impact assessment. The first one is what we call the divergent phase, where you have different synthetic personas with different biases and different points of view. You want this impact assessment to be done separately by them, and then you consolidate all the opinions, all the views of these stakeholders into a consolidated document. That is what we call the convergent phase. For instance, the risk discovery layer that could looks like a simple thing is not just asking an LLM to identify for me some risks. We have that part in the right with what we call the LLM discovery, where the LLM is directly asked, okay, can you identify emergent hazards, emergent risks that has not been described before? But we also have a pattern matching approach, where we leverage a curated library of well-known risks associated with specific design patterns or architectural patterns. So it's not just a stochastic generation of risks, but something that is governed by a previous knowledge that is provided to the system. And as I have explained it before, every risk is categorized by severity and by likelihood of happening, and that will provide you with the risk level in a kind of risk matrix, and that is what allows us to focus on the risks that actually matter. The next important component is the orchestrator plane. And the orchestrator plane, the key goal of this is to do the tool efficient. And that means that if, for instance, a small part of the system changes because there's a code commit or some technical document incorporates a small change, you don't need to do the risk assessment for the whole system again from scratch, but this orchestrator will identify which components of the system needs to be reevaluated, with which tasks and sequence of tasks needs to be executed, and so you save time and you save resources. Now going into the Pacific AI Brain, that are we think are the differential characteristics of our system, is what we call the hybrid intelligence. So the idea is, and I have mentioned this in a couple of slides before, this tool is not just prompting an LLM to ask, okay, give me the risk. Here you have this information. Tell me the risks and tell me the mitigation strategies. That is part of the system, because in some cases is useful, but it's more than that. Under the hood, what we have is a knowledge base of well-curated, deterministic, expert-vetted catalog of risks linked to specific design patterns, and catalog of mitigations, and a catalog of regulatory constraints. So that knowledge that takes time to build is what the different agents can leverage to provide with a more deterministic and more auditable risk analysis, apart from the stochastic or standard LLM queries. And regarding what I have mentioned about these regulatory constraints, we have a very useful layer here in the agentic execution that is a set of agents that is specialized in is what we call the regulatory abstraction layer, and is specifically designed to scout all the different regulations in AI that are in worldwide, and we cover international, federal, and local regulatory frameworks. And these agents are capable of read the regulation that usually comes in the form of unstructured content, identify a specific constraints or specific rules, and transform these rules or register these rules in a machine actionable set of constraints. So it's allow you to identify, okay, HIPAA is applying this policy that is common with the European regulatory framework, or has been not included in this new regulation. All this kind of granular analysis is available because we have this regulatory abstraction layer extracting the information into a machine actionable format. And all this information of this knowledge is stored in what we call the general assets registry. And that is what allows our system to do things like mapping technical patterns, or design patterns or technical motifs into specific regulatory risks. For example, it is able to identify, okay, this system is using an encrypted storage. So that will trigger automatically potential personal health information exposure. Or the system, the technical documentation tell us that we are using a third-party API to call to external LLM. That automatically triggers the data residency risk. So there's a lot of things that are predictable, and that are and that predictability is good for auditing. And of course, we can also, using this background knowledge, we can also suggest specific mitigations. And what is more important, we can tell you this mitigation has this specific effort. That is something very, very useful when the system provides you with a list of mitigations, so that will feed your backlog, and you will be able to make a decision, as we will see later, about what to do with the system. Just to finalize the final tips about how to manage the life cycle, we find in real world, we typically find two situations. The scenario A, here you see that is a small change in the system. It could be, for instance, for example, this code delta. So just imagine a developer team has decided we will adjust the threshold of face recognition, let's say. So we introduce this chain in the code base that is automatically detected by the orchestrator, that will decide, okay, given this small change, I don't need to reassess all the risk of the system, but I just need to focus on this specific set of risks, and I need to suggest this specific set of mitigations. So you don't need to redo all the work from scratch, but just focus on the specific changes. That allows you to introduce a fix sometimes in minutes or in short term, and you need to wait for months of reanalyzing the risk of a system each time something changes. That is a common problem with quality assessment in these AI systems. But sometimes you have the scenario B, where, for instance, something that affects several different number of projects, or maybe all your projects at the same time, something like the regulatory shift, some regulation changes, that will impact all the systems that you are evaluating or you are managing. So you need to update all these systems and customize the mitigation strategies for each of the systems. This is allowed by the existence of the governance knowledge object that can identify for each of the systems what do you need to change, and will incorporate these mitigation actions into the backlog of each of the systems separately. So at the end, you as a compliance officer will be able to make two different decisions. That is not just rejecting a system or approving a system. You will be able to say, I reject the deployment of the system because it's not ready, has some risks, but as I have a list of mitigations and I have a plan of a mitigation plan for the different risks, I can approve what we call the development posture, where I reject the deployment of the system, but I can approve with enough information that you will spend 6 months fixing implementing these mitigations that we have decided thanks to the system, to the risk assessment system. In conclusion, we think that by automating risk assessment, we can get into a situation where we can have innovation. We don't slow innovation, but at the same time, we will be able to have AI system that we can trust. I hope you have enjoyed this webinar. Please, any question, just contact me and let me know. I will be happy to answer.